Hey everyone, it's Eamon with ipXchange, and welcome to another projects chat with Alexandra Covor, who we actually spoke to at Maker Faire Rome. So it's great to talk to her again, but she's got more projects to talk about. So, Alexandra, what would you like to talk about today?
Hi, Eamon. First of all, good to see you again.
Yeah, no worries.
And today, I think I'm going to talk about this butterfly, the same one that we've seen at Maker Faire Rome, because it's my most recent project and my dearest, I would say.
Nice. So, in terms of the technology behind it. If I remember correctly, it's based around Raspberry Pi RP2040.
Exactly, the
Cool,
Pico.
cool. So when you were developing it, did you start off with like the standard um, Pico board and then kind of draw the designs from there? What was kind of your design journey?
Yeah, that's what I did. That's what I usually do with any project. If the documentation is really good, and that's the case with the Raspberry Pi Pico, I usually start off with their reference design, and then I build around that, adding the functionalities that I need. And that's what I did with this butterfly. What I added is 64 LEDs. I mainly built this because I had these really tiny LEDs that I wanted to use in a project. They are
Okay.
1 by 1 millimeter,
Oh, wow, that
and
is
I
tiny.
wanted to build some cool wearable using them. And I also wanted to make this as an educational kit. And I thought the Pico is a great choice for that because they have a lot of resources and a great community built around it.
Cool. So, did you say 64 LEDs?
Yeah.
So is that one LED per IO, or have you done some like crazy matrix type of thing where you can control them a different way?
Yeah, yeah, they are multiplexed, so I'm using multiplexer to create a LED matrix because I don't have that many IOs,
Yeah,
and
that's what I was thinking.
that's
It's like I don't
that's
remember having that
crazy.
many. Yeah. Oh, cool.
Exactly. Yeah.
So in terms of coding that, I'm guessing in MicroPython, how did you find that? Was it quite simple, or was it quite a challenge?
It's not exactly challenging. The only thing that bothers me right now, and that I
Mhm.
want to change in the future iteration, is that you cannot really have all the LEDs on at the same time because of the hardware for multiplexing the LEDs. So
Ah, okay. Yeah.
yeah, yeah. So you can see this. It's a
Mm.
problem. This is usually solved if your code is running really fast, so you can't really see the difference. But
Mm.
since this one is programmed in CircuitPython slash MicroPython, the code isn't that fast. So in a future iteration, I would like to use some NeoPixels. They are not as small as these ones. They are 1.5 millimeters wide, which is
Mhm.
still really small. And I think that would make the programming also easier for, let's say, a kid or somebody who's just starting with programming. And I don't want to confuse them with 64 LEDs metrics.
Yeah, that would be pretty crazy. I
Yeah,
mean, just checking with those LEDs, is what are they single color or are they multicolor? It's kind of hard to tell over the camera.
multicolor. They are RGB, so there's 3 pins per LED.
Oh my god! So that's if you were doing that one per IO, then that would be absolutely insane
Impossible.
number of. Yeah, yeah.
Yeah.
Okay. So was it just the LEDs on there, or have you put any other functions like buttons or anything?
Right now, there isn't any other function, but I also want to add a quick connector, so you could add any other sensors through
Oh,
I2C,
nice. Yeah.
yeah, I2C or maybe SPI, because that would really enhance its functionality. Right now, it doesn't do much, but this was the first iteration, and I just wanted to figure out the visuals and how much space I have left to add anything else.
Nice. And is that plugged in at the moment? Oh, it's running off a LiPo cell. I can see
It,
it in your hand.
yeah,
Nice.
and it's just there's a reset button, but it's really really small, like here.
Oh, okay. Yeah, I think I can see it.
Yeah.
Cool. So in terms of the, well, obviously you've redesigned the circuit board because there aren't. I don't know of any other butterfly-shaped circuit boards. So
Yeah.
what tools were you using for that? Or what software tools?
I'm using KiCad because it's open
Okay.
source, and again, the community is very good, so I can find pretty much anything I need in terms of symbols and footprints and add-ons, as those are important too.
Okay. And in terms of actually making the PCB, is that something you did in house, or did you use a third party company as the PCB maker? And how did you find that process?
We don't build the PCBs in-house, especially something with such small traces,
Mm,
because this one has 4 layers too, so it's super complicated. And it's not worth doing this in-house
yeah.
at this level. It's the costs would be higher than actually
Yeah.
ordering it. But the process of ordering some PCBs, it's really simple. Like I would say, just designing it is the challenge, and then ordering is not that complicated. And once you've done it once, uh, it's the same thing pretty much every time.
Cool. So with those 4 layers, what's running on those 4 layers? I'm assuming part of that 4 layer process is because of the 3 inputs for each LED, but maybe I'm wrong.
Yeah,
Okay.
exactly. Because it would be impossible to do the matrix without the 4 layers.
Yeah. Okay. Um, so in terms of I remember we talked. You also did the Pico Light as well, running on the RP2040.
Yeah.
Has that has the RP2040 become kind of like your go-to microcontroller at this point? And do you see yourself using more RP2040s for your later projects?
It definitely is for my educational hobby projects, let's
Mhm.
say, because I really enjoy teaching others the things that I also get to learn um, by doing these projects. So the Pico is great for that. But also, since I'm also doing electronics as my job and I'm
Mm.
doing more complex projects for different clients and with different use cases, I'm now also learning about Renaissance development boards, and I'm also developing some feather boards based on those. So these two, depending on the use case. Um,
Okay,
yeah.
cool. So Renaissance, that'll. I'm assuming that's. Are you? Is that still being? Are you still programming that with MicroPython, or are you using embedded C?
Uh, It's C because it's RTOS
Okay.
mostly, and they also have Linux running boards. But right now, I'm focusing on the RTOS ones.
And in terms of balancing MicroPython and C, which would you say are the advantages and kind of ease of uses of each of them? Because I remember switching from MicroPython to Arduino code, and then Arduino code has lots and lots of brackets, and you don't have to be so cautious about all the indents. But then the MicroPython code, everything was all about indents. So how did you find that going between those two?
Yeah, I actually hate the indents in Python because I started the first programming language that I learned was C++.
Mhm.
So and then I learned Python, and that I found that really annoying, and I'm still not used to it. But it definitely is easier for learning about programming
Mm.
since when you're a beginner. And Arduino is somewhere between the RTOS, C++, and let's say MicroPython, CircuitPython,
Yeah.
any of those. Um, so in terms of how easy it is to use, definitely MicroPython is a great choice. But then, like I said with the butterfly, if you want it to actually run fast and efficiently, you will need to learn C++ and use that one.
Okay. Do you think you'll do a version of the butterfly that uses C++ code instead of the MicroPython then?
I was thinking of that, and I actually want to do that for myself, but for the educational kids, I'm gonna stick to this one,
Yeah,
the
that
Raspberry
makes
Pi
sense.
Pico.
Yeah.
But yeah, I was also wondering if I could do this for myself with C++ and maybe a Renesas chip just for me to learn about it.
Cool. Just in terms of size on the board, do you think you'd be able to use the same board board size, or would you have to make it bigger to accommodate the Renesas chip? Because I've noticed the Raspberry Pi is pretty small in general.
Yeah.
So yeah, do you reckon you'd need to go bigger?
Well, actually, Renesas have a lot of microcontroller and microprocessors families, and they have some even smaller than the Pico,
Oh, that's cool.
and some monsters, huge monsters that are
Yeah.
really powerful and that are overkill for this project. So,
Mm.
yeah, I'm. They have many options, so I'm not worried about that. I can find one really easily. And also, if I'm switching the LEDs with some NeoPixels, I would also get much more space in terms of the routing area because I won't need that many traces.
Mm. Okay. So, is there uh, anything else you wanted to talk about regarding the project in terms of the design journey that you think might be interesting to other engineers to learn, maybe from any mistakes or any particularly big wins that you had?
Yeah. So the first thing that's worth pointing out is that this is a hobby project,
Mm.
and while I do the same thing at work, with my hobby projects, I simply allow myself to make mistakes, and I'm not that worried about whether the project will come out perfectly or as perfect as it can be in the first try, because I know nobody will judge me for that, and
Mm.
nobody's paying me to do this, so I can do whatever I want. And it also allows me to use whatever technology I need or I want to learn about. So again, the restrictions that I would have with customer project at work do not apply to these ones. And I think that's my process with any of my projects. And it's a great way to learn and have fun and not be stressed about it. So
Nice. Yeah, that's a good thing to take away from that. Um, Nice. So I think unless there's some other stuff you want to talk about, I think that's been a pretty good overview of the project, and I thought it was very interesting, and
thank you.
it's cool to actually learn a bit more than we could from the from the interview we did at Maker Faire Rome because that was so fast.
Yeah.
But yeah, it's cool to learn about the from my perspective the four layers and just how you did the multiplexing and stuff. I thought it was quite cool. So, is there anything you wanted to promote at the end of this interview in terms of your work or places that people can go to learn more about your work, either hobby or professional?
Well, if anybody wants to see other of my projects, they can do it at picacircuits.com. I recently made that to showcase my project because I didn't have a website previously. And I'm also active on LinkedIn or Instagram with my name. So please connect wherever you want. And reach out to me if you want to talk about projects, especially ones that combine art and electronics, because I'm very happy to talk about it.
Cool. And I think we can probably tease that we actually talked after Maker Faire Rome about one of your professional projects, the
Yeah,
for the featherwings
yeah,
or for the
the
featherboards.
featherboard.
So I think we'll keep that secret until it's ready, but then we'll have to definitely catch up and do another interview on that when those come out.
Yeah. By the end of January, that should be done. So let's talk again about that one.
Cool. Cool. Everyone can look forward to that. So again, thank you so much for coming on to the show, Alexandra. Always great to talk to you. And yeah, check out her work at picocircuits.com.
Yeah.
Hey, yo, where my engineers at?